Hello viewers, a warm welcome to you all to this online class, especially the students. Today's class will be a continuation of what we have did in the last class, that is refractive index. So in the previous class, we did the mathematical expression of refractive index. So refractive index, when light travels from medium P to medium Q, it is equal to sin I by sin R. This I is the angle of incidence in the first medium, R is the angle of refraction in the second medium. Then this also equal to speed of light in P and then divided by speed of light in Q. But when it is sure that the first medium is vacuum, we call it as the absolute refractive index of the medium. Then it is also equal to the wavelength of light in vacuum divided by the wavelength of light in the medium. Now this we have used by the formula V is equal to the wave speed equal to lambda wavelength into frequency. Now what is so important about refractive index of the medium? Now what can you say when you know about the refractive index of a medium? Now when light travels from one medium to another, you must know that a part of it is absorbed. We have this body, then light is coming, then a part of it is absorbed, then a part of it is reflected. This is when it travels from one transparent medium to another, and a part of it is refracted. A part of it is refracted. Now refractive index now mainly tells, it indicates about the light bending ability of the medium. The light bending ability. What? It says here that the more the bending of light takes place in the medium, the more will be the refractive index of the medium. Now let's take an example. Let's take an example. Let's take an example, where they've given when light travels from air to glass, and then when light travels from air to water. And they have given the refractive index of glass to be, with respect to air, to be 1.5, and refractive index of water with respect to air to be 1.23. Now note here that the first medium is the same. Is the same. Now, just by looking at this, you can tell that refractive index, which one is bigger? Bigger it is glass, that of glass. So when the refractive index, when this is bigger than this, you can conclude that more bending of light takes place in glass. When light travels from air to glass, more bending of light will take place than that compared to water. So when they give you the value of refractive index, then you can tell more bending of light takes place. So that is the conclusion that you can draw out. Then next is that refractive index, it is a pure number. Why is a pure number? Because it is a ratio of two similar quantities. Look, speed and speed, and then sin I by sin R. It is what like the units, they get cancelled. As a result, there will be no SI unit for refractive index. They will give you only the number with no SI unit. And the fourth point about refractive index is that the construction of lenses, in optical instruments, it depends upon the knowledge of the refractive index. You have to know first the refractive index of the glass, then they construct the lenses of the optical instruments like cameras, microscope, telescopes, and so on. And then another point to be noted about refractive index is that when we have two medium and the refractive index, they are the same, then no refraction takes place. No refraction takes place when they have the same refractive index. And another point is that when I told you, when more bending of light takes place in the medium, medium, higher will be the refractive index. Now why? Why? Because you know that when light it travels, more bending means it will bend more towards the normal. Okay. Then what happens to this angle of refraction? It will be quite less. Okay. And then sine r being monotonic increasing function, as a result sine r will also be lesser. Okay. And then the refractive index will be higher. Okay. That's why what happens when more bending of light, more refractive index, because of this reason. Okay. And another reason also is that more the speed of light, what happens to the refractive index? The refractive index will be less. The last class I said when the speed of light is more, we call what? Rarer medium, right? Optically rarer medium. Speed of light is less, we call it as optically denser medium. But those which have more speed of light, they will bend light rays lesser compared to those where the speed of light is more. Okay, like in water, no, the speed of light is more compared to glass. Okay, but then you observe that the refractive index, however, of glass is more compared to that of water. So they are inversely proportional. Okay, speed of light and refractive index. Now what are the effects of refraction? Okay, what are the effects of refraction? Now it is applicable in our everyday life, where we don't realize. Like why do stars twinkle? It is because of refraction. But a special type of refraction called atmospheric refraction, which will be done in detail in the next chapter. And then you also observe when you like a pencil, you immersed it in a glass of water. Not a glass full of water, but a glass partially filled with water, and then you will observe that at the surface where it separates the empty part which is air, I can say, and then the water below, you will find that the pencil bends. It will be in this position and then like this. So that is how it looks. You can try this at home. And then another is a pool of water. A pool of water, it appears less deep than it actually is. So that's why you have to take precautions when you go swimming. Sometimes you say it is not deep, and however you will discover after you go that is actually much deeper than what your eyes assume. So those are some of the effects of refraction. Actually there are many, but I've pointed just a few. Then next we'll go to lens. Now lens play a very important role in our everyday lives. Right from the cameras to the spectacles which people use, to the microscopes, the telescopes, and many other optical instruments. Lenses are used in making these. So what is lens? Lens is it is a piece of piece of transparent glass. It's a piece of transparent glass, but it is bounded either by one or two spherical surfaces. The detail about spherical surfaces will be done. Now lens the working of it is based on this refraction of light. You see, when light travels and when it passes through this lens, refraction takes place. So now lenses are classified into two classes, concave and convex and concave lens. Convex are also called as converging lens, and concave are also known as divergent lens. lens, now how can you differentiate, okay, between convex and concave lens? Okay, just by touching. Okay, suppose they give you convex and concave. Just by touching, okay, now you will find that convex lens, they are thicker in the middle, but at the edges they are quite thinner. Okay, now those are convex lens. But concave, they are what? They are thicker in the edges, but they are thinner in the middle. Those are concave lens. Okay, and concave lens also we have 3 types. Okay, we have, this is when both are bulging. Okay, this is double convex lens. Okay, now convex, okay, both are bulging, but in this case, okay, here you see that it is plain. Okay, this is plain, and then another is bulging, so convex lens. Plain, convex lens. In this case, you find that it is bent inward. Okay, bent inward. So this is concavo convex lens. Okay. Now in the case of concave, okay, they are bent inward. Okay, they are concave lens. And when both are bent, we call them as double concave lens. Here you find this plain, here bent inward, plain concave lens. However, in this case, it's bulging, bent inward, it is convex, so concave lens. Now this is a double convex lens. Okay, so mainly we'll be doing about double convex lens and double concave lens. Okay, so now this, okay, this portion, okay, is a part of this spherical surface. Okay, and this, okay, with this spherical surface and having its center of curvature. Okay, then the line passing through these two center of curvatures, okay, this imaginary line is called the principal axis. Okay, so this is called the principal axis. And then a line is also drawn, okay, within the lens, but passing through the aperture, okay, drawn through the aperture of the lens. Aperture means the diameter, okay, this end, okay, the end of the lens, you drawn from here, and then it is perpendicular to the principal axis. Now the point where it meets the principal axis, okay, it is denoted by O, called the optical center. Okay, optical center. Okay, and then, okay, in the lens, okay, there are principal focus. Okay, principal focus. Now, in the case of a convex lens, we have the first principal focus and we have the second principal focus. Okay, so what is this? Okay, first principal focus and what is the second principal focus? Now, the first principal focus, okay, it is a point on the principal axis, okay, such a way that when light rays emanating, okay, is originating from it, okay, what happens? When they pass through the lens, they will come parallel. They will become parallel. This is the first principal focus. Okay. The second principal focus, however, okay, when light rays, what happens? When they travel parallel. Okay, when they travel parallel, and then as soon as it hits the lens, okay, when it passes through the lens, okay, as a result of refraction, they will meet at a point, and this point is the second principal focus. Okay, so that is the first and second principal focus, and make sure that the distance, okay, of the first principal focus to the optical center should be equal to the distance of the optical center, okay, to the second principal focus. And this distance, okay, we call it as the focal length, okay, denoted by F. It should be the same, remember, okay, they are the same, and focal length, it is the distance of this to this, or distance of this to this. And then we have this focal plane. Focal plane, it is the, when you pass a plane through this, okay, like a piece of paper, you pass through this, that is called the focal plane. Pass through the first or the second principal focus. Okay, that is the focal plane. Okay, now we'll go to the double concave lens. Okay, so this is a double concave lens, and then it is a part of the spherical surface. This is a part of this spherical surface. Okay, by two spherical surfaces with their own centers of curvatures, C1 and C2, and then the line passing through this, through these center of curvature C1 and C2 is called the principal axis. Okay, just like for concave lens. And then a line is drawn through the drawn within the lens. Okay, then drawn from the aperture. Okay, and then it will be perpendicular to the principal axis. And the point where they meet, that is called the optical center, denoted by O. Okay, capital letter O. And then we also have the principal focus. Okay, in the case of concave lens, F1 and F2. Okay, so this is the first principal focus, this is the second principal focus, and make sure the distance of this and the distance of this, they are equal. Okay, now this, what is this? Okay, this is the first principal focus. Now this is a point where when parallel rays of light, okay, when they pass through this lens, they will diverge. Okay, diverge means that they appear to meet at this point. Okay, like this. Sorry. It should be this. Sorry. And then all of them will appear seem to be coming from this point. Now this is the first principal focus of the concave lens. Okay. However, what is the second principal focus of the concave lens? Now this is a point, okay, on the other side, okay. But then now you will find that, okay, this is F2, okay. Now we have this lens here. Now there will be rays, okay, seem to be passing through this focus. Okay, there will be rays passing through this focus, but however, as a result of refraction, they will become parallel. Okay, when they pass through the lens, they will be parallel. Okay, as a result of refraction. But actually, when you extend these incident rays, okay, they seem to be going to this F2, okay, that is the second principal focus, okay, of the concave lens. And the distance of the optical center to the first principal focus, it is called the focal length, denoted by F, okay, and this also F, okay. So either first or second, the distance of optical center to the first or second will be called the focal length. Okay, and again, focal plane is when you pass either to the first or second. Okay, that will be called the focal plane.